In the previous video, we learned how to perform principal components analysis. In this video, we'll move one step ahead and perform kernel principal components analysis. PCA is good at reducing the number of dimensions, but it works in a linear manner. If the data is not organised in a linear fashion, PCA fails to do the required job. This is where kernel PCA comes into the picture. You can learn more about it at this documentation. Let's see how to perform kernel PCA on the input data and compare it to how PCA performs on the same data. Let's go back to our editor. Let's first create a new Python file, kpca.py, and import these packages. Now, define the seed value for the random number generator. This is needed to generate the data samples for our analysis. Next, generate data that is distributed in concentric circles to demonstrate how PCA doesn't work in this case. Now, let's perform PCA on this data, and now perform kernel PCA on this data. After this, we go on and plot the original input data, and now plot the PCA transformed data. Now plot kernel PCA transformed data. Finally, let's transform the data back to the original space using the kernel method to show that the inverse is maintained. Now let's move to Command Terminal and run this file. Once you run this code, you get 4 outputs. The first figure is the original data. The second figure depicts the data transformed using PCA. The third figure depicts the data transformed using kernel PCA. Note how the points are clustered in the right part of the figure. And the fourth picture depicts the inverse transform of the data back to the original space. In this video, we performed kernel principal components analysis to reduce the number of dimensions of the non-linear data. In the next video, we'll perform blind source separation.